Hello, we're going to do the second in the spotlight in chapter 4, designing a count control loop with the for loop or for statement. Your friend Amanda just inherited a European sports car from her uncle. Amanda lives in the United States and she is afraid she will get a speeding ticket because the car speedometer indicates kilometers per hour. She has asked you to write a program that displays a table of speeds in kph with their values converted to miles per hour mph. The formula for converting kph to mph is mph equals kph times 0.6214. In the formula, mph is the speed in miles per hour and kph is the speed in kilometers per hour. The table that your program displays should show speeds from 60 kph through 130 kph in increments of 10, along with their values converted to mph. The table should look something like this. So it shows the table there with the different values on there. Okay. After thinking about the table of values, you decide that you will write a for loop. The list of values that the loop will iterate over will be the kilometer per hour speeds. In the loop, you will call the range function like this: range 60, 131, 10. So it'll start at 60, increase by 10 at a time, and it will stop when it gets greater than 130. The first value in the sequence will be 60. Notice the third argument specifies 10 as the step value. This means the number in the list will be 60, 70, 80, and so forth. The second argument specifies 131 as the sequence's ending limit, so the last number in the sequence will be 130. Inside the loop, you will use the target variable to calculate a speed in miles per hour, and then there's program 414 in the book is the code, which is what we're going to work on now. So get this moved over. I already have a program from the last time, so I'm going to open up a window off of that or a file off of that so that I have it available. When I get ready to save it, it'll go to that directory and I don't have to go hunting for it. So again, I'm going to leave comments out, save some time. We're going to have 4 named constants. The first one is start speed, which is going to be equal to 60. The second one is end speed, which is going to be equal to 131. Next one is increment, which is going to be equal to 10. And then conversion factor, which is going to be equal to the 0.6214. At this point, we're going to print the headings for the table. So we're going to do KPH and then a \T to put a tab in, and then MPH. Then we're going to print a series of underlines. Whoops, put my quote mark in there. Underline this, and then if it doesn't look good, we can go in and modify. Do our for loop. So for KPH, in range, and it's going to be from start speed to end speed, incrementing our increment. So our MPH is going to be equal to KPH times our conversion factor. And then we want to print, use the F format for this, curly brace, KPH, end curly brace, \T to tab over, curly brace, MPH, end curly brace, oops, sorry, not yet, colon, dot 1F, for the format, end curly brace, end quote, in parentheses. So that's the code for this. So I'm going to go ahead and get this saved. And I'm going to save it as speed converter. .py. Save it in the same folder where I have my other one because they're both chapter 4s on there. And then we'll run this and see if I got any errors in here. We need to look at anything to fix. Squish this down. Yep, everything looks good. We just need to put a couple more, say like 3 or 4 underlines on there, so we can clean that up real quick. Or actually, they're dashes, not underlines. I'm going to put four in it, and then I'll run it again. And that's better there. So, okay, any questions on that? Talk to your instructor about this, and then we'll get going with the next video so you have that to look at. Bye.